Dr. Sridhar, back to you with another video session on mesh analysis. And in today's video session, I am going to discuss about nodal analysis also. These are the basic laws and these are the basic analysis techniques we are going to use to analyze the electrical networks. So basically what happens, this mesh analysis and nodal analysis are the fundamental techniques. We are going to use these techniques to know the currents through various branches or the voltage drops across various elements in the connected electrical networks, and that is because of connected voltage sources or current sources in the circuit. So first, knowingly or unknowingly, very many times we used to utter mesh analysis, or this another name of this is loop analysis. And what is this mesh analysis and loop analysis that we are going to discuss in today's session? Just coming to this introduction part. So how can we define this mesh analysis? Any closed electrical path is called as a loop. Mesh is defined as a loop which does not contain any other loops within it. So see the sensitive difference between loop and mesh. Mesh is defined as a loop which does not contain any other loops within it. But loop may consist so many loops internally inside of it. That is the only sensitive difference between mesh and loops. So mesh does not contain any internal loops inside that particular mesh. Now in the normal sense, we can say it is a closed path. Either it may be a mesh or loop. It is a closed path, and inside that closed path there should not be any other closed paths within it. Then that is called as a mesh. So mesh is nothing but is only a starting point or terminating back and at the starting point, which is nothing but it is a mesh. But loop is something different. Loop, inside that loop we may find few more loops based on the orientation of various electrical elements in the electrical network. So that is the difference between mesh and the loop. So without knowing this exact difference between mesh and loop, we cannot proceed further. So that's why I have given the definition for the loop and mesh separately. Loop may consist of another loops inside it, but mesh is nothing but only one single loop. It will not have any loops internal to it. So that is mesh. So if a network has a larger number of voltage sources, it is better to use mesh analysis, which mainly depends on Kirchhoff voltage law. So here there are two types of electrical networks. Broadly, if we could see, so that electrical circuit may consist of many voltage sources or sometimes many current sources or the combination of it. So if any electrical circuit consists of more number of voltage sources and current sources or the combination of voltage and current sources, source transformation technique is highly used. So the source transformation technique is benefited for us to make the nature of voltage sources unique. Either voltage sources can be converted to the current sources or current sources can be converted to the voltage sources. Based on the objective of us, if we want to determine the current, then every voltage sources can be bring to the current source with the help of source transformation technique. So this source transformation technique is highly helpful for us if the combination of the different sources, if we can find in the electrical network given. But only if purely if the electrical circuit consisting of more number of voltage sources, then mesh analysis is preferable one. If the electrical circuit consisting of more number of current sources, then nodal analysis is preferable one. So that before moving into the electrical circuit analysis, now by seeing the circuit itself, we should get some idea. So which technique is more apt to analyze the behavior of that electrical voltage sources or current sources in the connected system. So the thumb rule is, if any electrical circuit consisting of more number of voltage sources, mesh analysis, and consisting of more number of current sources, nodal analysis, the combination of these two, then source transformation is preferable one. Now source transformation will not give the complete analysis, but basically in order to simplify the network, that source transformation is highly helpful for us. Now what are the steps we had to follow in the mesh analysis? First, we had to identify how many number of meshes. So carefully you should know the difference between mesh and the loop. So by having the knowledge and the difference between mesh and loop, then we can go for earmarking the number of meshes in the electrical circuit. So that is the first step. Second step is sign conventions of IR drops. I mean to say, now if there are some passive elements are there, through that passive element, how much of current it is flowing. So that current is nothing but the current available in that particular mesh. So first step is we have to identify the number of meshes. Then you have to go for the number of mesh currents required. So every mesh should have one mesh current, and whatever the orientation of that mesh current is also very, very important, because without knowing the orientation of that mesh current, we cannot easily identify the drops polarity across various passive elements in that particular mesh. So of course we are going to use Kirchhoff voltage law at the latter, but before proceeding into the Kirchhoff voltage law, across every element, we had to earmark, or we had to identify whatever the voltage drops. Now voltage drop is nothing but the product between the current which is flowing through it and the resistance in that particular branch. So that resistance or the impedance into that current will give us the IR drop. That is nothing but voltage drops. Now along with the voltage drop, we should be more careful about the voltage source polarity also. Whenever you are traveling from lower potential to higher potential, we are going to gain some electrical energy, so that the voltage battery or the battery or voltage source will be assigned as a positive polarity. So for better understanding also, I am giving here, suppose if this is the voltage source, this is a negative polarity and this is a positive polarity. So these are the terminal A and this is the terminal B. Now if you are traveling here like this is my movement, the movement. So during this particular movement, first I am going to touch the negative plate of the battery, then only you are going to touch the positive plate of the battery. So negative to positive we are moving. So because I am traveling in this direction from A to B, so in this traveling, so first I am going to touch the negative terminal, then I am going to touch the positive terminal. So in this case, so whenever you are traveling from negative plate of the battery to the positive plate of the battery, it is assumed that the voltage source magnitude V is going to gain some energy, so that is treated as a positive. So this voltage source will be assigned as a positive. So sign is nothing but the positive. So similarly, if we are taking a voltage source like this is point A and this is point B, and this is the positive plate of the battery and this is the negative plate of the battery, and the magnitude of the battery is V, and if we are moving in this particular direction, this is the movement. Then see, first A to positive plate of the battery, okay, then positive to negative plate, negative to B plate. So what happens here? So positive to negative means we are traveling from A to B. So in this path, first I am going to touch the positive plate, then negative plate. So what happens? I am going to lose some of the electrical energy. So why? Because positive to negative. So positive to negative you are traveling means indirectly some of the electrical energy was dropped between these two plates. So that polarity is nothing but it is treated as a negative polarity. So this is nothing but the negative polarity. So these are the, so whenever you are talking about the voltage sources or batteries, so you should keep these 2 points in the mind. So whenever you are traveling from A to B, if first of all you come across with the negative plate of the battery, then positive plate of the battery, then the polarity can be treated as a positive polarity. Otherwise what happens? First of all, you come across with the positive plate, then negative plate, means the polarity can be treated as a negative polarity. So these are the 2 things we should keep in our mind while you are applying Kirchhoff voltage law for that simplification, for the analysis purpose of the particular loop or mesh. These are the 2 things about the batteries. Similarly, you may come across with the resistors. Suppose if the resistor is like this and the current flowing through this resistor is like this. So from point A to point B, the current is flowing, and whenever you are applying Kirchhoff voltage law or something else, now if you are moving in this particular direction, if this is a movement and this is the current direction, so this is the current direction. So in that case, the drop is nothing but the drop is IR, that is a potential drop. And here the thumb rule we have to remember that is the current and the movement direction both are in the same direction. You mark it as a negative polarity. So this drop across this resistor is nothing but the minus IR. And one more thing is, suppose the same case here, this is the resistor, this is the point B and this is A, and the movement is from B to A, this is the current, and this is the current, and this is the movement direction is from A to B. Then in that cases, if the current and our movement are in the quite opposite direction, then treat that potential drop as a positive drop. So these are the four important things we have to remember while you are analyzing to know some current through any branch or drop across any passive element with the help of this mesh analysis or Kirchhoff voltage law. Now these are the four very most important parameters, most important things. You should not forget about this. So if you know these four, now you can play with the electrical circuits wherever you can apply Kirchhoff voltage law or mesh analysis or loop analysis. That will be very simplifier. So that is the thing. That's why I am highlighting here. Now how this voltage source polarities we can take in order to simplify or in order to analyze the electrical circuit means these two things will give us complete emphasis about the voltage sources. Similarly, the drop IR drops across various passive elements also. This might be very helpful for us. Now if the movement and the current both are traveling in the same direction, treat that IR drop as a negative, otherwise positive. So like this, I am going to determine various sign conventions of IR drops and sources and batteries, battery maybe EMFs like Kirchhoff voltage law, and after that apply KVL around the mesh, and you can use Ohm's law with which we are more convenient. You can make use of that basic electrical technologies, associated theorems or principles. Then you can make use of that particular statements to simplify the given electrical network by applying Kirchhoff voltage law or Ohm's law for the interested mesh or loop. So it will give a mathematical equations, and you can simplify with the help of algebraic equations or matrices. If more number of meshes are involved in that electrical network, then we can make use of some crackers matrix associated statements to simplify the electrical networks. And at the end, if you could solve simultaneous algebraic equations, you will get the various currents associated with various meshes. So in the next coming video, we can make use of this mesh current analysis to simplify the electrical networks, and I am going to discuss by solving one or two problems also. Thank you for watching this video. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.